Good evening, everyone. Waiting for others to join in.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Still, people are coming in. There are quite a few still to come. We'll give another minute. Your school is over? No classes now, right?
No, sir.
Okay, so you have a lot of time, nothing else to do. You can't go out. Have they started optics in your school?
No, sir.
So we just started, but that was on the last day.
That was NPS HSR you're talking about.
So NPS Indranagar.
NPS Indranagar. NPS Indranagar just started. What about others? In NPS HSR, what is going on?
So we finished with we were doing electric current, and then we had some portion of it left.
Say it again. Some portion of?
Electric current, sir.
Okay, current electricity you were doing.
Yeah, current electricity.
Okay. That is NPS HSR. Freedom, Akansha. Where is she? She is not here. Okay. Then any other school? That's all. Mehul, what are you whispering? I can hear. All right. So today we are starting this topic, ray optics. Okay. Still people have to join in. Come on time, guys. You're not anywhere roaming around here and there. You're in the home only. So you can do this thing. Right. So I will start. Let others join in between. So today, again, I'm saying we are starting ray optics. Fine. Now, before even starting ray optics, let me just give you a brief of what we are going to, talk about under optics and then ray optics and all that. Okay. By the way, is there any lag when I speak? Like I'm writing something here. Is there a lag? RAYOPT. Is there a lag?
So a
Very
little bit.
less. Very less.
Very less. So that will be gone anyways. Okay. No lag. Okay, no lag actually. So if there is a lag, probably some internet issue, not from my side. Okay. So all of you, please write down optics first. Write it very, very beautifully, very nicely. Write down optics. The reason is this is the chapter which can give you free marks. Okay. When I'm saying free marks, of course, a little bit of effort is required. But having said that, this this is first of all not a chapter. Okay, optics is like a section itself. For example, thermodynamics is a section. Okay, just like thermodynamics and just like mechanics, electrostatics, optics is another section of physics. Okay, and the best part about this section of physics is that it is not connected to anything else in physics. All right, for example, electrostatics was very tightly connected with all the concepts of mechanics. So whenever you solve problems, there used to be concepts from mechanics used to pop up, and you need to be good at mechanics also in order to attempt the electrostatics questions. Okay, but here is a chapter, guys, which is completely disconnected with everything else you're going to study in physics. It is not connected to electrostatics, not connected to magnetism, not connected to current electricity, not connected to mechanics. All those concepts are not going to get utilized in optics chapter. This is a standalone topic or standalone section of physics, which stands on its own. So you can learn from scratch and master it, and you must get all the questions correct in this section. Okay, because there are not many varieties. All right. So that is one very nice thing about optics. You can get 100% marks, and you can get very easily as well. Fine. Now, with respect to the weightage of optics, easily around 8 to 10% will be the weightage of entire optics, and you can see that in your book, optics is divided into two big chapters. Okay, there are two chapters of optics. Write down. One is ray optics. Other is wave optics. Okay. The best part about ray optics is that you have already studied in class 10th. You already studied the lens law, the mirror formula. You know the basic ray diagram. You know parallel rays, when it reflects, from where it will pass through, how the ray diagram and all that will behave. So it is just a little bit of more extension to whatever you already know. Okay, and which you have learned in class 10th. But I will not assume that you know anything. Okay, I am assuming that you guys don't know anything about ray optics. So I will start from the scratch. I'll start from right basics. Fine. Now, ray optics, you can say easily, is the second biggest chapter after the first chapter of electrostatics. You can say ray optics is the second biggest chapter. Wave optics is also a big topic, but not as big. Okay, so basically, why there is a split of the chapter under optics? One is ray optics, other is wave optics, because these are the two completely different way of understanding the light. Okay, so like I said, in optics we are basically studying it's a study of light, right? So I should have told that first, but since it came up, I'm writing here. Optics is a study of light. Now, can anyone tell us that why we should study light? What is the reason we should study light? Anyone?
So it's dual like nature, so we should study both natures of it, and just like the general belief is also that light always travels in a straight line, but there's phenomena which like
Why should I study? I know whatever you're trying to say, I understand that it behaves weirdly at times, something else will happen and whatever was expected. But why should I study at all? What is so important about it? So like what Sai is saying, it helps us to see. Okay, the light actually enables humans to see an object. Okay, now seeing is what? Seeing is like an observation. You are observing something. Fine. So basically, light helps you to observe anything in the nature. Okay, and observation is one of the most basic element of entire physics. Okay, if you can't observe something, you cannot measure it. So it is not a useful concept of physics. In physics, you measure everything. So you need to observe. Okay, so when you are talking about the speed of lion, let's say lion is running, so first question will be where it is, can I see? Okay, if I talk about displacement of an object, you will first draw the coordinate system, find out where the object was initially, where it is finally, you like to see it. Fine. So that's the reason why whatever is helping us to see, there is a need to study it. Now, why we are so much concerned about the light itself, because light can play tricks to our eyes. For example, very basic example, when you look up the sky, you see that one star is there. Okay, if you don't know basics of optics, you may tend to feel that star is a very small size object. Okay, so because of the optics, how light behave, there's a basic understanding of that. You will know that since star is very far away, it will look to be a smaller, so don't get fooled by how it is looking to you. Okay, another example could be when you're looking at the star from the earth, you may feel only one star is there, but when you use the astronomical telescope, then you find out there are multiple stars at the same location. So basically, when you're looking from your naked eye, the light plays tricks to your eye. You may feel that only one star is there, but in reality, there are multiple stars. Okay. Similarly, when you look at the Jupiter in sky, it looks like a star to you. But when you use astronomical telescope, you may see the details of the Jupiter. You may see the red giant is there. There is a red spot is there inside the Jupiter. All those basic things of Jupiter that you can visualize and see from the Earth is visible by using a good astronomical telescope. Fine. So that is macro level. At micro level, you cannot see bacteria or viruses. All right, so you can only see it by magnifying it, by using the lens and mirrors. Okay, so these instruments which you are using to enhance your vision will be only possible, you will be able to design them only when you have a basic sense of how light behaves. Okay, how image gets formed, how the magnifications will be visualized. Okay, so if you understand the basics, a basic principle or the laws the light follow, then you can create instruments to visualize or to enhance your vision. Fine. So that's the reason why we are understanding the behavior of light, how it behaves. Okay, now depending on one scenario, light can behave like a ray, and depending on another scenario, light can behave like a wave. Now, can anyone tell what is ray? Ray means what? When I say behaving like a ray, what does ray means? What it is? What is ray?
So it's something that travels in a straight line.
So basically particle nature.
Correct. Basically particle nature. Okay. So when Newton was, right, Newton was a father of many things in physics and for the ray optics also. So correct. So when Newton was, developing his theory on Newtonian physics, laws of motion, work by energy, and all those behavior of masses, so he was fascinated by the idea that everything in the universe can be understood by assuming it is a particle only. Okay, so even light, the Newton thought, is made up of particles. Fine. And these particles are not photons. The name of the particle was something else, the particle of the light. Okay, so he thought that light is made up of particle. Not only just light, he used to think that even heat is a fluid which flows. So basically, he was completely fascinated by the idea that everything is particle only, and he used to tell everyone, or he used to create a hypothesis saying that these particles of light do not get influenced by gravity. because there is no influence of gravity, once they attain a velocity, they go in a straight line. Fine. And hence, he used to say that my study of light is ray optics. Okay. In fact, he did not use ray earlier. He used to just say it is optics. Okay. But then there were another set of great scientists. The father of wave optics, his name was Huygens. So they used to think that light is a wave. Light is not a ray. Okay. Can anyone tell what is a wave? We have studied in class 11th, the last topic. What is a wave?
It's a periodic oscillation or disturbance in some medium.
That is SHM. What is wave?
So a collection of SHM.
What?
A collection of SHM, small SHMs, a huge collection of them.
No. Wave.
Propagation of energy.
When there is a wave on a surface of water, water is not wave. Are you getting it? Water is just a medium for the wave. What is wave? Wave is a disturbance. Okay. It need not be any periodic or any, very nice looking thing. It can be some random disturbance in a medium. It may require medium, it may not require medium. Fine. So wave is just a disturbance, and you cannot pinpoint where the wave is because the disturbance could spread in a particular area or volume. For example, from here to here, let's say in this zone, there's a disturbance. So this entire zone has wave. You can't say, okay, this is a wave. This is a point at which wave is. Okay. So you cannot pinpoint the location of wave. So the wave phenomena is completely different from particle phenomena. That is the reason why if you're studying light as a wave, we should study it separately, not combined with the ray optics. Fine. So, the ray optics and wave optics, both the idea came up together actually. Not too much of difference was there. But whenever something used to come up as, let's say, as an experiment to prove that wave optics phenomena exist, Newton used to oppose it because Newton was, completely in favor of that light behaves like a collection of particles. Okay. So whenever something came up, because Newton was very influential also, he used to, completely nullify that and used to say that same thing which you are explaining by assuming light as a wave, I can explain it by using my ray optics. So he used to completely, because of that, the idea of wave optics never came up properly. Okay. But then one scientist came up whose name was Young's. All right. He gave a very nice experiment which we will study in wave optics. His experiment was Young's double slit experiment, which completely failed ray optics. So Newton cannot explain what was happening in Young's double slit experiment. Okay, and that experiment can only and only be understood by assuming light as a wave. So from that point onwards, wave optics came up on its own, and then there were two different branches of optics or study of light. One was ray optics, other was wave optics. So these are the two behaviors of light. Okay, now when you try to answer what is light, you should not say light is both ray and a wave. Okay, you don't define something or someone by its behavior. Okay, for example, let's say I want to for example, let us say any student, let's take Param. Okay, Param may, if suppose Param is happy, so he will behave in one particular way. Okay, if Param is sad, he will behave in some other way. If Param is with someone, he will behave in another way. So like every other person, everyone has hundreds of shades of behavior depending on different scenario. But these behavior do not define you. I will not say Param is a sad person or Param is a very happy person, right? It only depends on the circumstances or what is the scenario like. Fine. Similarly, the light also. light can behave like a ray in one situation, in one set of situations, light behaves like a ray. Okay. If I change the situation, light starts to behave like a wave. Okay. So you need to first understand what is the situation and then understand whether I should apply ray optics or wave optics, because these two behaviors are completely different. Okay. For example, let's say, you know that some person is very angry. So you don't like to, discuss something with, so you need to first understand what is the scenario and then pick up which principle you'll apply, ray optics principle or wave optics principle. So the scenario in which we will apply ray optics, that we are going to discuss first in the chapter called ray optics. Fine. So all of you, please write down this chapter, ray optics. Do you know there is another name to this chapter, ray optics? Anyone? Anyone knows it? Series of compression and refraction. Oh, that is that's last question's answer. Ray optics. Do you know any other name of ray optics? Anyone? Okay. The another name is geometrical optics. Now, what does the name give indication of? What can you say when you hear such name? Anyone? When you hear a name like geometrical optics, what do you think the implication of that will be? Or does that give you some idea what will be there in the chapter? Anyone?
So it tells us that most of the optics will just be like, since we assume that light is going to travel in a straight line, then like most of the questions can just be solved through similarity and things like that. Like it's a very geometrical study of where light will be and what the magnification.
Correct. So this chapter will revolve around lines, angles, trigonometry, geometry. Okay. This chapter will be full of it. Okay. So in fact, you can say that this chapter could easily be belonging to mathematics, not physics. Fine. So the concept of physics will be just a formula, but when you analyze a particular situation, more or less it will be geometry which you'll be analyzing it. So that is why people have gave this name geometrical optics. But mind you, these geometry will be very simple one. They will not be very, very complicated geometrical scenarios. So don't worry much about it. Okay. Now, geometrical optics, I will categorize what we are going to learn in this chapter, because this chapter is very big. Okay. Not only just that it is big, we are going to learn many small things. Okay. Since many subtopics is there, it makes sense to categorize the information. Okay. For example, if you need to learn about the elements in chemistry, first thing you do is learn the periodic property, learn the periodic table, how everything is categorized, and then take one by one, right? Otherwise you'll go mad. You first study hydrogen, then helium, lithium, magnesium without even knowing any trends. Okay. So that's the reason why, since many things are there, let us first categorize what all things are there, and so that we can create buckets in our brain, as in what we are studying. So there are 4 buckets of information. All of you write down, or you can draw also. Better if you draw. Better I'm drawing. So like always, I'll be moving very slowly initially. So pay attention initially, very, very intently you should listen, so that later on when speed is slightly higher, you will be able to grasp the max. So there are 4 buckets under ray optics. The first bucket comes under reflection. Write down, this is reflection. Okay. Second bucket is refraction. You first write down, then I'll tell you what it is. And I am sure you guys know what it is anyways. Refraction. Reflection and refraction are phenomena. There will be other phenomena also that we'll be learning. And there is the last part of the chapter is optical instruments. Fine. Of course, you need to have optical instruments. You are learning so much so that you create some optical instruments, right? So after you learn all these phenomena, you need to also understand about the optical instrument. So that is why optical instrument is there, but it cannot be at the start before you learn about the phenomena. That's why at the end. Okay, so under reflection, we are going to first learn about reflection from plane mirror. Okay, then we will learn the reflection from the spherical mirror. Do you know the kinds of spherical mirrors? Do you have any idea? Have you learned about them? What are these spherical mirrors?
Concave, convex.
Convex.
Convex and concave. Very good. So convex and concave are the two spherical mirrors. Fine. So these are the two spherical mirrors. The first one is convex. The second one is concave. Okay. Now, reflection is a kind of phenomena. Okay. So there will be laws of reflection. So one kind of phenomena will have one kind of laws. Reflection will have one kind of law. Refraction will have another kind of laws. So you need to understand when reflection is happening, you need to apply laws of reflection. When refraction is happening, you need to apply law of refraction. So can anyone tell me what is the difference between reflection and refraction? Anyone?
So reflection is when the light hits a like opaque surface and comes back, whereas refraction is where the light passes through the medium and undergoes like a change in path, apparent change in path.
Okay. So, all right. Someone else also texted. You can please type in, okay? Please keep it interactive. Don't hesitate to type in whatever comes in your mind. Don't just sit quietly, okay? It returns to same medium in reflection. Very good. So, when it comes to reflection, the medium is not changed. That's a very mathematical definition that we will take. So if light is traveling in a medium and suppose it changes path, but it remains in that medium only, then there is a reflection going on. Fine. In refraction, the medium is changed. For example, when the light is traveling in air, it goes inside the water. The medium is changed. Or light is traveling in water, goes in air, then also medium is changed. Light was inside water initially. Okay, so law of refraction will be little different from law of reflection. Okay, and in the refraction, the first thing you need to study is what will happen at the interface. As in, when the light is, let's say you have a bucket of water. Okay, you have a bucket of water. This is water. Okay, and over here there is air. Okay, light comes like this and goes in. the water like this. There is no lens, nothing. It is just an interface between the two mediums. So we need to understand how the refraction happens at the interface. Okay. So first we will learn about plane interface. If the interface between the medium is plane, which usually happens, for example, when you put water in a bucket, a plane interface gets formed. Plane interface. Okay. And then you will learn about a spherical interface. A spherical interface can be concave or convex. Fine. What I mean to say is that the spherical interface can be like this, where this is glass, this is air, and light comes like that and goes inside the glass. So this is a concave interface. Similarly, it can have a convex interface. The interface could be like this. Fine. So this is what I mean when I say the spherical interface. Okay. So we will learn about the spherical interface, and then we are going to talk about lenses. Fine. So write down lenses. How lenses are different from interface? Anyone? How it is different from interface? Two interface. Shreya says two interface. Any other? Any other? Okay. It passes through a second medium and then leaves that medium. The light goes back to the correct. That's what I wanted to hear. The lens, what happens is both sides of the lens will have same medium. Okay, this is a very important criteria. If you change the medium of one side of the lens, you cannot use lens formula. Okay, so both sides of the lens, if they have the same medium, you can treat it like a lens, which we'll be discussing here. Okay, light goes from, let's say, air to the medium of lens, then again goes back to the air. That's what. This is lens, about lens. Then we will discuss about the prism. Why we are discussing about prism? Because prism will tell you an experiment to find refractive index. We'll discuss what is refractive index. I'm just writing here. So basically, prism is a device which you can use to determine the refractive index of the medium. So that is why we are discussing it here. Have you guys done that experiment where you used prism to determine the refractive index? Anyone in standard 10th?
Yes, sir. I've done it.
Okay, so that is what we are going to discuss mathematically. How does it look like? Okay. Other phenomena are dispersion. Dispersion is splitting of multiple wavelengths in the light. So right now, till reflection, refraction, we are assuming all the wavelengths in the light are going in the same path whenever refraction or reflection happens. But in reality, dispersion happens. So different wavelengths of the light will split. Okay. So if you look the white light through the prism, you will see that different colors will come out. Okay. So that is dispersion. The second is scattering. Okay. Good thing is there is no numerical on dispersion and scattering. It's a theoretical topic only. Okay.
So does diffraction come under here?
What? Say it again.
So diffraction.
Diffraction is wave optics. It doesn't come in the ray optics.
Okay.
Okay. Now in optical instrument, which two optical instrument comes in your mind? Basic ones.
Telescope, microscope.
Microscope, telescope.
Microscope, telescope, right? So that is what is there in our syllabus. So first one is microscope. Write down. There is a simple microscope and compound microscope. Okay. There is microscope and then telescope. Basically, simple microscope has lesser magnification. If you use compound microscope, your magnification can go many folds up. So that's why there is such thing. So telescope will have astronomical telescope. And there is this another one, Cassegrain telescope, which is towards the end of the chapter. Okay. So in astronomical, usually the telescopes which are very strong, you need to use a huge lens. So I don't know whether you've seen it in movies or any documentary. Typically the astronomical telescopes will be on top of a mountain, okay, and the entire roof will be a lens only, okay. So the size of lens is very big. Now when you use the lens of that size big, it is very difficult to maintain it. It becomes very heavy and it may chip off from the corner. So that is why Cassegrain is another design of telescope in which rather than using the lenses, they are using mirrors, which are a lot lighter and easier to handle. Okay. So this is your entire curriculum of or entire chapter, ray optics. Fine. Is there any doubt in this classification? Anyone? No doubts?
No,
No
sir.
doubt. Okay. So we are going to start reflection today, and it may happen that that is all we can do today. Reflection. Fine. Mind you, reflection and refraction together constitutes around 80% of this chapter. Okay. So other phenomena is just little bit of introduction. Optical instrument, you can say 10 to 12% of. So reflection and refraction are the major ones. Refraction is the biggest topic, and reflection we can study today, and we'll solve few numericals based out of it. Write down reflection. Okay, so throughout the chapter, there is one basic assumption, and whenever we are studying the ray optics, please assume that light travels in a straight line in a medium. So if light doesn't change the medium, okay, and doesn't get reflected anywhere, it will keep on going along one straight line. That is what the ray optics is. Okay. Now, reflection, like what many of you have told, is a phenomena in which light deviates its path but remains in the same medium. Okay, so basically you can say light bounces off from a surface and it comes back to the same medium. Fine. So is it a random process or there are some laws which light follows? Of course, like you know, light follows some process, light follows some laws, and this is what we'll start from. So write down laws of reflection. Okay, tell me, what is the first law of reflection?
So incident ray, reflected ray, and normal all lie on the same plane.
Okay. So there are two laws. The first one you have spoken. What is the other one?
Angle of incidence
Reflection
equal
is
to
equal to angle of incidence.
Angle of incidence is equal to angle of reflection. Okay. So that will write first. There is nothing called first law and second law. Okay. It's not Newton's law, first law, second law like that. So the first law we'll write is angle of incidence, which is referred as I at times, is equal to angle of reflection. Okay. So what is this angle of incidence? Angle between
the normal
The surface and the normal.
surface and the normal.
the incident ray and normal. Incident ray and normal.
Incident ray. Incident ray and normal. Normal should be where?
90 degree to the
At the point of reflection. Understood? So this is the angle of incidence. Normal should be at a point of reflection. Normal to what? Perpendicular to what? Perpendicular to the surface at that point. Okay. Now, when you draw the normal, does the surface need to be horizontal or it can be curved also?
it can be
It can be curved, sir.
It can be curved. The law doesn't say that it has to be flat surface. Okay. Angle of reflection, angle R, is the angle between the reflected and the normal. Okay, so this is the first law that we have written. The second law, like what someone said, the incident ray, reflected ray, and the normal all lie on a same plane. So basically, suppose I take what is the third pen? Right. So suppose I have these three things. Okay. Now, if the middle one is, let's say, normal, and the red one is the reflected, the black one is the incident one, then all of these three lines should be in a plane. So when you look at it like this, it should look like one, you should look only one line should be visible to you. Okay, then only you can say it is on a plane. But if it is like this, now they are not in one plane. Okay, so basically what is with you is incident and reflection. Normal is not given to you. You can draw normal in any which way. Okay, but the second law tells you how you should draw the normal. Normal should be drawn in such a way that it is in the plane containing incident and the reflected ray. This is what comes out of the second one. Okay, so if you take the plane surface, okay, if you take a plane surface and let's say a ray hits it like this, at the point of incidence, the first step is to draw the normal. Okay, normal will be vertically up like this. This is normal. Okay, and the second one, the second step is finding out this angle. Okay, this angle is angle of incidence I. Okay, the light will be reflected in such a manner that the reflected angle, which is made by the reflected ray and the normal, I should be equal to R. Angle I should be equal to angle R. This is how you should draw the diagram of the two rays. Okay. Now suppose you have a spherical surface. Okay. Let's say you have a surface like this. Okay. This is the center. Now I want you to draw the ray diagram. So suppose a light hits like this. Okay. And see this shading, if I am showing here, shading means that the other side is the reflecting surface. So when I shade on the bottom side of the line, the top one is a reflecting surface. It is shiny surface. And similarly here, when I'm shading the inner surface of a sphere, the outer surface is the reflecting surface. So all of you, please draw the ray diagram, show the incident angle and the reflected angle. All of you try doing it.
So there's a bit of lag when you're speaking.
Is there a lag, all of you?
For me, it's fine.
That's fine for me.
Yeah, so just check your net connection. Many times it is from my side, but today I think it is not from my side. You can probably rejoin quickly. Okay, done?
Yes.
All right, so where is the normal? Normal will be this line connecting the center to that point, right? Normal to the sphere will be line connecting center to any point, right? So this is a normal at that point. This is angle of incidence and angle of reflection should be equal. So it will reflect off like this. So it will follow the law of the reflection so that this angle is R. Okay. Any doubts till now? Anything that you want to ask or discuss? Anything? No doubts? Nothing?
No, sir.
Okay. Fine. So I'll give you one question. All of you please do it. Suppose you have a mirror. Okay. You have this mirror. Light is incident on it. Light comes, incident, and the angle of incidence. Let's take whatever angle of incidence. It could be theta, phi. Let's say angle. This angle is phi. Angle of incidence is phi. Okay. And the reflected ray will be like this. That angle will also be phi. That is law of reflection, right? So this is also phi. Now what you're doing is you're rotating the mirror by an angle of theta. You rotate the mirror by an angle of theta so that the mirror becomes like this. I'll take theta to be lesser. This is your new position of the mirror. Okay. You need to tell me how much the reflected ray will rotate. What is the angle of rotation of the reflected ray? This reflected ray will rotate how much? Try it, all of you. This angle is theta. The mirror rotates by an angle of theta. Those who are good with geometry will answer immediately. Okay. All right. So, okay. All of you answer it. Half of them are anyway answering wrong, right? So you as well answer yours also. Okay. The answer is 2 theta. The answer is 2 theta. So, Pradyut, can you explain how it is 2 theta?
So when you rotate your mirror first, you add an angle of theta to your incident angle. And in addition to that, when your reflected ray is getting reflected, so first off, you've already rotated it by an angle of theta, plus it's now going to get reflected by another theta because your normal's also been tilted that way. So it becomes 2 theta.
Okay, so basically you're saying is normal rotates by an angle theta. The first thing you'll notice that the normal to the new surface is not the same normal, right? Even that will rotate by an angle theta, isn't it? This is angle theta, normal to the new surface, this one. So the angle of incidence, see, incident ray will remain like that only. Incident ray will not change. So angle of incidence will be phi plus theta. Okay. So angle of reflection should also be phi plus theta only. Right now it is theta plus phi after the normal is rotated. So basically the ray will reflect off in such a manner, this is, let's say, new reflected ray, such that this angle is theta plus phi, isn't it? Now you have to get that angle. How much is this? Right? So how it is 2 theta? Did you understand that now? All of you? This angle is how much? This one. This angle.
Phi minus theta.
This is phi minus theta. Okay. And this total angle is theta plus phi. This total is theta plus phi. This one is phi minus theta. So the rotation of the reflected ray will be what? This angle minus that angle, which is 2 theta. Theta plus phi. See, the best thing about the geometrical problem is that if you do it yourself, it will be easier. If somebody explains you how the angle and all that, it tends to be a little bit more involved because a lot of scribbling needs to be done and demonstrate the angles. So I hope most of you have understood. Any doubts, anything, please ask. Anyone? The trick is the normal also rotates by an angle theta. That right now normal is like this. With the mirror, it rotates by an angle theta. So now incident and the normal is making theta plus phi. So the reflected ray with the new normal will also make theta plus phi. Okay. The earlier reflected ray makes an angle of phi minus theta with the new normal. So the angle between the two reflected ray becomes 2 theta. Okay, so just do a little bit of geometry, you will understand it. Shreya, Pranav, Mahit, Abhiram, Rajdeep, and Hiya, have you understood?
Yes, sir.
Okay. All right. Assuming all of others also understood, if you're not, please type in. I cannot take 25 people's name at one side. Anyways, so this is just a basic introduction of how the chapter will be going forward. So now one thing in which our entire attention will be is formation of image. Okay, whenever we study something, formation of image will be there. Okay, So for example, when we study the mirrors, 90% of the question will be find the image of an object. When we talk about the lenses, reflectant or the interface, 90% of the questions will be to find the image of the problem or the image of the object. Okay. So what is this image? First, we need to understand what is this image is. Then only we can hope to find it. Okay. We need to understand the basics of what is image, basics of how it is getting formed, and then only someone can ask you to find out what is and where is the image. Okay. So please write down, this is a very important topic, nobody talks about it. Basics of formation of image. And this basic which we are discussing, it is valid in all, whether it is mirror, lens, prism, interface, anywhere, microscope, telescope, everywhere these basics will be applied. Okay, so this topic doesn't come under reflection. This is a universal topic. Basics of formation of image. So like always, I will start with a question. What is image? Anyone? What it is? Image क्या है भाई? Anyone? Let's talk about image of some person. Okay. Image is in perception. Very good. Very good. Image is nothing but perception. How you perceive it. Okay. How you perceive it. Perception can be manipulated. Perception can be manipulated, right? I can be a very nice guy for 1 or 2 days. You'll perceive me a very nice guy and will be very happy-go-lucky. But then perception can be manipulated, and so will be the perception of how you observe or how you look at object. Even that can be manipulated. Using lenses and mirror, you can get tricked by the perception of the object, which is the image. Have you ever been in a I think there is, like, whenever you go to these kind of places, I don't know what they are called, water park or something, there will be a place which is called mirror house or something, where you go in. Mirror maze, right? So you perceive as if nothing is there in front of you, you go and hit the mirror. Okay, so your eyes are playing tricks on you. The reason is the perception is not the reality. Okay, so but then this is what you observe, isn't it? If you talk about observation, like if I am observing something, I can only observe the perception, right? I can only see the image of an object. So at least how you perceive it, that you need to understand first. How image gets formed, that you need to understand first. Then you can understand how you are getting manipulated. For example, many a times the mirror will give you inverted image. Erect object, but inverted image. So if you already know that inverted image will be formed if object is somewhere, then you will not be tricked. Fine. But then you should know that how image is getting formed, because at the end of the day, you are not looking at the object, you are looking at its image. Fine. So in simple terms, image is nothing but perception. Please write down. Of how object is. Okay. When I say how object is, I'm only talking about how does it look like. Okay, so object is looking. When I'm talking about how it is looking, I'm just only interested in the height of the object and where it is placed, and that's all. Okay, so these are the perceptions. Now, how the perception gets formed or how the image gets formed, that also we need to understand. Okay, so let's first talk about process. How image is getting formed. What is the reason image gets formed? Anyone? What is the basic thing that should happen so that image will get formed of an object?
The object has to reflect some light onto something. Like the light from the
Voice is breaking. Anyways,
I'll type it.
I understood, but what you were trying to say. So basically, light from the object must reach the light from the object should reach where? Anyone? Should reach the observer or observer's eye. Okay, whenever I say that there is no observer in this chapter, I am only interested in the eye of the observer. So if I say the observer is here, I'll just draw an eye. This is the observer. Okay, so when light from the object, write down, light from the object reaches the observer's eye. Okay, image gets formed. Why we are so much interested in finding the image? Why I cannot directly look at the object? You can look at the object directly. So for example, when you are standing in front of mirror, you can look at yourself directly like that. Okay, but you will not be able to look at your face because of the geometrical constraints. Your eyes will not pop up like that and look at you, right? You need a mirror. So you need to look at your image on the mirror, then only you can see your face. Okay, and similarly many other scenarios. Sometimes you can't even visualize properly, or you can't see the bacteria, so you need to magnify it and look at its image. You can't look at the stars properly or planets properly, so you need to bring it closer by using telescope and look at the image. Okay, so images are very important to observe something in a very careful manner, but at the same time, images can play a trick. So you need to be also aware of how image gets formed and what all tricks it can play so that you don't get fooled by it. All right. So light from object should reach the observer. That's how image will get formed. Okay. So suppose this is the observer. Observer is somewhere on the right hand side. Okay. I said this is the observer. Although I have drawn observer at just one little eye, it doesn't mean that entire ray should go inside the eye only. I can say whatever rays go backwards, the observer will catch it. Okay. So suppose one ray is coming like this. One ray of light goes inside the observer's eye. Observer, can I say that observer will feel that the image or the object is along this line only? Can I say that the image of the object, since the ray is coming from here, so if ray of light is coming from there, I look at it like that, then only it will be visible to me. So I'll say that along this line, the image should be or object should be. Can I say that?
Yes, sir.
Right? But can I locate the location of the image? No, I cannot, but I can only say that along this line somewhere the object is. Okay. Now, if I have two rays coming from the object like that, okay, two rays are there. So observer will feel that the object should be along this ray because this is coming from the object, and it should be along that ray also. Okay. And this is the common point. Okay. So basically observer will feel that the object is here, which is the perception of object. So it can be image also. Getting it? All of you understood? So if two rays are there, their intersection will be the image, because observer will feel as if these two rays are originating from that point. Clear? Any doubts? Anyone? Arey bhai, anyone has any doubts? Am I audible?
Yes, sir. No doubt, sir.
Okay. Fine. So now let us see how you can get tricked. For example, these are the two rays coming from the object. So if there is nothing in between, your image will be directly on the object. Object and image will get coincide. But if suppose there is a kind of lens here, which we will discuss later on, what it does is it deviates the light like this. If it deviates the light like that, then what the observer will feel from where the light is coming from? Will the observer feel that light is coming from here? Where it will feel the light is coming from?
So when you join
When you draw the two lines backwards,
It'll
the point of
be
intersection.
the intersection.
Correct. So when I join them backwards like that, observer will feel that the light is coming from here, because that is the intersection of these two rays. Although light is not there, but observer will feel that light is coming from that point. So this is your object and this is your image. And observer will feel as if that is where object is residing at the point of image, but there is nothing there. Okay, so using lens and mirror system, you can shift the location of object and create its image. And when you create the image, it can get magnified, it can get diminished, it can get inverted, it can be erect, it can be laterally inverted, right will become left or left will become right. So many things can happen. Okay, so we need to understand how these things will happen in case of mirror when we talk about the reflection, and we will talk about same thing, the formation of image, when we talk about refraction, the interface and the lenses. Okay, so since we are talking about reflection, let us now see how image gets formed in case of the mirrors. Okay, I'll take the plane mirror first. So plane mirror is, let's say this is a plane mirror. I've drawn it vertically. This side is shaded. So the front one, the left hand side, is the shiny surface and it can have reflection. So suppose there is an object over here, object O. I know all of you know the answer. I want you to draw the ray diagram to find out where the location of image will be. What is the first step in drawing the location of image? Anyone? First step is what? What is the first step in drawing in finding out the location of image?
So we draw two rays onto
That is not
the
the first step.
mirror and we draw the.
That's not the first step. First step is identifying where the observer is, because light from the object should reach the observer, right? So where the observer is, where it is. Can the observer be here?
It's on the left side.
On the left side. So can it be here?
So it should be behind the object. Like we can assume it to be.
It should be behind the object. What is the reason it should be behind? If it is behind the object, we'll directly look at the object, no? Like this. Why it will look at the mirror?
So there's no reason. We can put the observer anywhere on the left side.
I can put it anywhere on the left hand side. But I am assuming observer is not directly looking at the object. That you must know. I am assuming that observer is looking at the rays that are coming from the mirror, not from the object directly. Understood? Now draw the ray diagram. The ray should reach the observer. Done with the ray diagram? Okay, done. Here is done. Others? What is the easiest ray to draw here? Easiest one.
So one perpendicular to the mirror.
Perpendicular to mirror. So if there is a ray that goes straight along the perpendicular like this, what will happen to this ray?
It will reflect back without any reflection.
Why? What is the reason?
Angle of
So angle of incidence is 90. Yeah, 0.
Angle of incidence is 0. So it will just go straight back. Okay. So you need to remember that, I mean, of course, it is something obvious we are writing, but it is worth writing that a ray, because there can be curved surfaces also, a ray along the normal, please write down, along the normal will retrace its path back after reflection. It doesn't matter whether there is a curved surface or a straight surface. Okay. Now the second ray, I need two rays, right? Right now the observer will feel that the image will be along this ray only, the single ray, but that will not help to locate the image. So I need to draw the second one. For the second one, I have drawn the ray, and this is the incident angle. This is the second ray, that is the incident angle I. Okay. This is how it will reflect. This will also be I. Okay. Now you have two rays, ray number 1 and ray number 2. Wherever they intersect, that is the location of image. Okay. Now in reality, they are not intersecting. So you need to do some construction. You need to drag it back like this, and this ray also. So it appears as if the reflected ray is coming from here. It appears. It is actually not true, but it appears as if it is coming from that point. So image is basically there. So the perception of object is here. So this is your image. That is your object. So how much is the distance of object from the mirror? Anyone?
2D.
This distance.
D.
This will be D. How? How?
So the two triangles will be congruent.
Two triangles are congruent. These two triangles are angles 90-degree. Side is common. These two angles are also equal. Congruent triangles. So that is why all the sides and angles are equal. Okay. So that's the reason why this will happen. Okay. Now, do you guys know about real and virtual images? Have you studied in 10th?
Yes, sir.
What is the difference? Real and virtual images? In real images, the two reflected ray will actually intersect. The reflected ray that comes out will actually intersect, and at the point of intersection, there will be a real image. Okay. Over here, they are not actually intersecting, but they appear to intersect backside. So this is a virtual image. This is not a real image. Okay. So you know that a real image can be captured in a screen because there is a light. So you can capture the light on the screen. But virtual images cannot be captured on a screen. You can't put a screen backside of the mirror and capture it. There is no ray there. Okay. Anyways, characteristic of the image of plane mirror. Please write down. Same distance behind the mirror. Okay. Same height. As the object. This is characteristic of the image. Okay. We haven't drawn the height of the object, but even if you draw the height of the object, it will be same thing. Okay. So for example, there is a mirror. If height of the object is like this, the image will be like that. Okay. Every point along this object will have an image equidistant like that. Collection of points, you can say the entire object. Same height as an object, it is erect, but laterally inverted. Can you tell me one example of lateral inversion from the mirror?
So left becomes right, like your hand.
Right. So when you stand in front of mirror, your right hand becomes your left hand in the image. But then the real life example will be like, have you seen in the ambulances? The ambulance is written from left to right in a reverse order.
Yes, so that the rear view mirror of the car in front can see like it written properly.
Correct. So when you look at from the rear view mirror of something which is already inverted, will look to be in a correct order, because inversion of inversion is the correct order. So this is the characteristic of the plane mirror. Always remember that the object and images will be at the same distance. Okay, during the online calls also, my image is inverted, is it? This is my right. Does it look like left to you? This is right.
No, sir.
No, right? It is right only. Inverted. Advik is saying it is inverted. All right, so let's take two questions. Take Advik. Oh, it's okay. Focus here. Suppose this is a person. It's a person. Okay. The person's height is capital H. Capital H is person's height. And this is the eye of the person. You are assuming at the top top of his head, the eyes are there. Okay, eyes. You need to tell me what is the size of mirror required by the person to look himself completely in the mirror. What should be the height of mirror the observer should have so that he can observe himself completely? All of you do this. Height of the mirror required for the observer to look himself. Okay, Mahit got it. Others? Nobody else? All of you please try it. It depends on where the mirror is kept. No, it doesn't depend on that. If it depends, let's assume it is at a distance d away. Then you try it. Let's say you have this much mirror. Whatever is minimum required, you keep that and you can erase rest of it. So I'm just drawing it like that. Let's say this is mirror. How much of it is required to you? Can I say that if the person is able to look at his feet, the entire person visible to him, right? So if the person is able to see the feet, it means light from here, from the feet, should reach the eye. Like that. Getting it? So this should happen. All of you understand?
So can you explain that again?
If light from the feet has to reach the eye, so this should be followed or not?
Yes, sir.
Right? Okay. And the person wants to look at his eyes. How should he look at it? Where the rays should be?
At the same level.
At the same level. So light from the eye go and hit the mirror and comes back. So he is able to see his feet and his eye from here to here. So can I say that he can look himself completely in this much size of the mirror? Can I say that? Only this much mirror is required. All of you understand?
Yes, sir.
How much is that?
Yes, sir.
H by 2.
H by 2.
H by 2.
Is h by 2.
Right.
So
H by 2.
h by 2. This is the normal to the mirror. The law of reflection will follow. This is angle of incidence, angle of reflection. Both are equal. So that's the reason why this triangle will be congruent of that, and hence this height is h by 2. Okay. Fine, clear to all of you. We'll take one more. Then that way it is h minus h by 2, which is h. Correct. That is what I'm saying, bro. Okay, we'll take one more example. Let's say you have a mirror. Okay. This is a mirror, and along this line, which is normal to the mirror, okay, along this line, an object can move. There is this object which moves with, let's say, 2 meters per second. With what velocity the image will move? What will the velocity of image?
So like the image as seen by this guy who's running.
No, the absolute image. Sorry, absolute velocity. 2 meters per second is absolute velocity. I am asking for absolute velocity of image. Two meters per second only, right? Both the object and image should reach the mirror together. If image is moving faster, image will move and reach the mirror first. Object won't be able to reach, but the distance of object from the mirror should be equal to distance of image from the mirror. That's why both the velocity should be equal. So the image should also move with 2 meters per second, right? Now a small twist. The mirror is, let's say, moving on the right hand side with, whenever I'm asking what is the velocity, I mean absolute velocity. We have been following this, right? Okay, so let's say the mirror is moving with 1 meter per second. Now find the velocity of the image. Which concept are you using?
Relative velocity.
They'll start off at the same distance and have to reach the mirror at the same time. So
Okay. Fine. One thing remember is relative velocity with respect to the mirror will be having same magnitude for the object and image. If relative velocities are equal, then only they will reach the mirror together. Okay? Relative velocity of the object with respect to mirror is how much?
1.
2 minus 1 on the right hand side. Okay? So if, let's say, velocity of the image is, let's say what, x, this should be equal to what? X?
X plus 1.
X plus 1.
X plus 1. Okay? So you will get it as 0 meter per second. So the image will not even move. The absolute velocity of image is 0. Understood, all of you?
Yes, sir.
All right. So this is the plane mirror. Now we are going to discuss about these spherical mirrors. Okay. I can make many tricky questions out of just plane mirrors, but they are not as many as there were in mechanics. So you can just practice, let's say 5 or 10 of them. You're good to solve any question. Okay, please write down spherical mirrors. Now, before I even start the spherical mirrors, I need to list down all the assumptions that we will follow when we talk about spherical mirrors. And in fact, the lenses also everywhere throughout the chapter, these are the assumptions that we follow. Okay, what are these assumptions? I'll create a list of it. All of you please write down. It will not be specified exclusively anywhere in the question also. They will assume that you know these things. So the first assumption is the observer is always near to the normal. Okay, whenever image gets formed, it automatically implies that angle of incidence and angle of reflection are very small. Okay, that automatically implies that sine of I is roughly equal to tan of I is roughly equal to I. Okay, similarly, sine of R is roughly equal to tan of R is roughly equal to R. These are the three assumptions which are valid in entire chapter whenever image gets formed. Fourth, you know what is aperture? Anyone? Aperture or size of mirror or lens. It is size over here. Okay, size of mirror or lens is very small. It automatically means that if we drop a perpendicular from any point on mirror or lens, it will be very close to the center of mirror or lens. Center is pole and optical center. I'm not using the technical terms because I haven't told you yet. So what I mean to say is that suppose this is the mirror. Okay. Point number 5, very important, is that if I drop a perpendicular, then this point is very close to that point. This point and that point, they're very close. I can say that these 2 points overlap. Understood? Clear?
Yes, sir.
Okay. So this is the assumption we follow, that these 2 points will overlap. And this is a common construction. Okay. Point number 5 is a common construction. Throughout the chapter, you're going to do that. It's a common, very, very common construction. How does it help? Common construction. It helps by generating right angled triangles. It generates right angled triangles, and hence we can use trigonometric ratios, similar triangle concept, easily. So you can write sine theta, tan theta, cot theta easily because it is a right angle triangle. So it's a common construction that we follow. Okay. Point number 6. That is not the assumption though. Okay, so these are the most important assumptions which you get to know after the chapter gets over. Okay, so I'm writing here before even starting it. So I'm going to use these assumptions left and right, and we will not discuss why we are using these assumptions, because if you do not have these assumptions, your mirror formula will not look like the way it is looking so simple. Your lens formula will also not look like something which looks very simple. Okay, the entire optics will become very complicated then. That is why these assumptions are, you can say, founding stones of the study of ray optics in class 12th. Fine. Any doubts with these assumptions? Anyone? Please ask.
So I understand the 5th point. Like
What?
Like what do you mean by it? Could you explain it again?
I explained 2-3 times already.
So one more time, there's nothing wrong.
No.
Please.
So basically what I mean is that, see, the aperture is very small, as in this size of the mirror is very less. Okay, so when size of mirror is very less, it is like, one example you can take, for example, Earth. If you look at a very small portion of Earth looks to be a flat. Okay, so right now it looks to be a curve, but if you take a very small portion of it, it looks to be flat. So if it is like a flat surface, which I'm drawing to be curved right now, then if I drop a perpendicular from any point on the mirror like that, then this point will be very close to that point. Are you getting it? So if
Yes,
it is
sir.
like this, if I drop a perpendicular, this point is very close to the center of the, that is what I want to say about 0.5. Understood?
Yes, sir. Thank you.
Any other doubt? Anyone? No doubts? Doubtless? Okay. Fine. So continuing with spherical mirror. Why it is called spherical mirror? Anyone? Rajdeep, why it is called spherical mirror?
But it's curved.
Curve need not be sphere, right?
Yeah, but
It's
it
a
looks like
part of an imaginary sphere.
It is part of a sphere. Okay. A spherical mirror is a cutout from a sphere. Okay. So let's say I cut out from here to there. Okay. Point number 1 to point number 2, if I cut out, then I'll get a piece of the sphere. Let's say this surface I polish, then the left hand side can reflect. Okay, but if I polish the other side, then the right hand side will reflect. So I can get two types of mirrors, right? If I take the other side polished, if I polish this side, I'll get right hand side to be reflecting surface. If I polish the inner surface, I get outer surface as reflecting surface. So basically I'm getting two types of spherical mirrors. One is called concave, the other one is called convex mirror. Can anyone tell me which one is called concave and which one is convex? Anyone?
The second one is concave.
Second one is concave. How you remember it?
So it's like a spoon for concave.
It looks like a cave. You can say it is a cave sort of thing. Okay, when the rays come from here, it's like you're going inside a cave. So like that, you can just remember it, that the second one is concave, the first one is convex. Okay. So we are going to see how images are getting formed in convex and concave cases. Fine. So initially, I will first draw the ray diagrams only and see that how we can visualize the images, how it is getting formed. Okay. So before we even get into the ray diagram, we need to understand few things, as in few things which define a mirror. Okay. Definition of a spherical mirror. Suppose I give you a spherical mirror. What is the first thing you will ask? What is the first thing you'll ask? Talking
Which
about
side is it polished on?
parameters. Okay. You'll ask which side is polished. You can see it yourself, na? It will be easier to identify. But anyways, yeah,
Yes.
you can ask whether it is a concave or convex. That is like fine. The other one, what is the next thing you'll ask?
So the radius of the sphere of which it is.
Radius of the sphere. Very, very good. So radius of curvature. You can say curvature. There is no longer a sphere. It is a curve. So you say that radius of curvature. Radius of curvature is the radius of the sphere of which that mirror is part of. Radius of curvature is written as letter capital R. Okay. Other thing you'll notice about it is aperture. Aperture spelling is correct.
So there should only be one P. That's it.
Yeah, I thought so. Aperture of the mirror. Okay. The third thing which you should be sure about is the axis. Axis of the mirror. Where it is, anyone? Is a line connecting what? Connecting what?
Center of curvature and the center of mirror.
Yeah.
Center to any point. Center to any point on the mirror. Okay. Principal axis is what you are saying. Principal axis is center to center of the mirror. Okay. There is another thing which is called pole. Okay. Pole is the center of the mirror. Okay. So these things, all these things are called geometrical parameters. Please write down all of these things. They are called geometrical parameters. Why they are called geometrical parameters? It depends on the geometry. Okay, nothing else. Whereas one thing, the focus or focal length. What it is, anyone? What is focus?
The point where the image is formed.
Okay, others, what is focus? Anyone remembers it?
The point where all the rays converge, or at least appear to converge.
Parallel.
Point where all the parallel rays to the principal axis converge, right? Sorry. Sorry. So it is a point where parallel rays to principal axis converge. Okay. Now, is focus a geometrical property or optical property? It tells you about geometry, focus, or it tells you how it behaves with the light.
How it behaves with the light.
How it behaves with the light. Okay. Fine. So basically, this is the optical property. The last one is optical property. Fine. So if you know the focus, you will know that you will get a sense of how much it will bend the light. You will have an idea of what is going on. Okay. So that's the reason why focus is also an important parameter. In case of mirror, there is a straightforward relation between focus and radius of curvature that we'll discuss. But in case of lenses, it is not so straightforward. So do not think that f is always r by 2. No. Okay, only in case of mirror that is true. Okay, so these are some parameters. Now we will quickly derive a relation between f and r. Like I already told you, f is equal to r by 2. We will try to define it. In the process of definition of, or in the process of derivation of that, f equal to r by 2, you will understand how you can deal with the assumption, okay, that we have listed down. So let's say this is the concave mirror. And one more thing, guys, that sometimes I will discuss only about the concave mirror. And if I do not discuss about the convex, I don't need to discuss it. That is why I'm not discussing the convex separately. Reason, same thing is valid for concave as well. Okay. Now this is the, what all things are clearly visible to you? Aperture, size. This is the center, which is called the pole. Okay. This is principal axis. Okay. You can say that this is focus. This is F and this is C. Fine. Now I want you to draw. No, focal length doesn't depend on the aperture, but then anyways, you're taking aperture to be very less. In entire chapter, the aperture of everything, lens, mirror, whatever you consider, is very less. Okay, so now suppose the parallel rays are coming in. Okay, let's say parallel rays are coming like that. Where it will go?
Through the focus.
Through the focus, like that. Okay. Now I want you to draw the incident angle and the reflected angle here. How does it look like? All of you try this.
So what do we have to do?
Show the incident and reflected angle. Done. Where is the normal? Anyone? Where it is?
So does it pass through the center of curvature?
Correct. So it will pass through like this, center of curvature. This is a normal. Any line passing through center of curvature is normal. That is why it is called axis also, any line. Fine. And by the way, I forgot to discuss that. How the lens looks like. If you look at from front, how does it look like? If I look at like this, how the lens will look like to me? Will it look like a leaf? How does it look like? A circle. It is a circle. It looks like a circle. Okay. When you cut out from a sphere, it will have this sort of structure. Okay. A bowl sort of thing will come out. This bowl sort of thing is your lens. Okay. So basically, you are only seeing what is happening in one plane. Getting it? So remember, this is a 3D thing. The mirror is 3-dimensional in nature. So the height of the object, when you draw the height of the object, the height can be like this. It can be like that also, because whether you are like that or like this, mirror treats both of them similarly, because it is ultimately a circle only. But anyways, all that you will deal when you do some higher order questions. Fine. So this is your angle of incidence I. This is R, which is also equal to I. How much will be that angle? This is how much?
2i.
2i. Okay. Now, what is the construction I have to do? Common construction. What is that?
So you drop a perpendicular from that.
Drop a perpendicular.
Right. That's a common construction. Every time you have to do that. So do not forget to do that. It creates a right angle triangle. This point is what? P only. Aperture is very less. Assumption was this point is P only. Okay. And let's say this height is H. Okay. So I can say that tan of I is equal to H divided by this distance from here to here. How much it is? Center of curvature. Distance is radius of curvature. So this is H by R. Okay. And tan of 2i is H by the focal length. Focal length is represented by F. Okay. Now, again, one more assumption. Angles are very small. So tan of I is I. Tan of 2i is 2i. So I is equal to H by R, and 2i is equal to H by F. From here, you'll get H by F to be equal to 2H by R, or F equals to R by 2. Okay. So this is the mirror formula, and this is valid in all the mirrors. Okay, all the spherical mirrors, concave, convex, whatever it is, every time this is valid. You can take homework to derive this expression in case of convex mirror. Okay, in case of convex mirror, take it as a homework to derive F equal to R by 2. All right. Now, can you tell me what is the radius of curvature of a plane mirror? Anyone?
It's infinity.
Infinity, right? F is infinite, R is infinity, so will be the focal length. Okay, so that will be the case for the plane mirror. So whatever you do here on, for example, you define the mirror formula, let's say. In the mirror formula, F will come. You can use mirror formula for plane mirror also. Take F as infinity. Okay. Fine. So now we'll take a small break. After the break, we'll continue and draw some ray diagrams, how images get formed from the concave mirror. Okay. Any doubts with whatever we have done till now? You can ask anything. Anything you want me to repeat or something? Okay, no doubts. Fine. So we will take a break now. Right now it is, oh, it's not 6. It is 5:56. We will meet after 15 minutes. How much it will be? 6, 6, 11.
11.
Okay. All of you, please come back after 15 minutes of the break. Okay. All right. Okay, so all of you back?
Yes, sir.
Fine. Okay, couple of students yet to arrive. Anyways, have you guys done the assignment? The assignment on the electrostatics, everything, all the assignments. Have you done?
So the CET JEE one I've done, the chapter-wise assignment, like the topic-wise of the assignments I've done.
Okay. How many of you are done with the assignments? Okay. So clearly the lack of time is not the reason. Okay. You cannot ask for more time than what you have currently. So I just wanted to highlight this, that, you know, it is not about you getting time or not. It is more of intent, whether you want to do or not. Okay. So if you don't want to do, in a day also, if I give you 50 hours also, then also you cannot do it. Okay. It is not about time. All right. So I think everybody is here. So we can now continue. So we are talking about the image formation on the concave mirror. So we'll be taking few cases and see the characteristic of the images, and then we'll proceed further. Okay. Case number 1. The object is at infinity. Where the image will be, anyone? If object is at infinity, what kind of rays it will generate? Incident ray will be how?
Parallel.
Why? Object at infinity generates parallel rays. Why and how?
So
Since the
we
object
say
is at
that
infinity and
Okay, here is the thing, guys. So if let us say this is your mirror, okay, if you're very close to the mirror, this will be the angle. Okay, if you're a little far, the angle between these two rays decreases. If you go little bit more far, angle between the two rays further decreases. So if you go to infinity, this angle theta tends to 0, and then you can say this ray and that ray becomes parallel. Okay, so that's the reason why if object is at infinity, the rays will be parallel to each other. Now tell me, does a ray need to be parallel to the principal axis?
No.
no, sir.
No, right? So I can change the orientation of mirror and my principal axis will be making some angle with the parallel rays, right? But right now I'm taking a case in which the parallel rays are parallel to the principal axis also. So let's say this is the principal axis, fine, and the parallel rays are coming like this. Where the image will be? So this is F, this is C. The image will be where? At the focus. All of you understand this, right?
yes, sir.
Yes, sir.
So basically the reflected ray will intersect over here. So the observer will feel as if the image is getting formed there. Okay. Now, what if the parallel ray makes some angle what if it makes some angle with the principal axis? Let's say this is the concave mirror. Let's say that is the principal axis, this one. And the rays are coming like this. These are two parallel rays. Where do you think the image will be formed? It'll be at focus or somewhere else? Where do you think it will be getting formed? It will get formed on the focal plane only. Okay, so basically the image will be on this line only somewhere. Are you getting it? It may not be on the principal axis now, but the image will be somewhere along this line. Okay, so if you draw the ray diagram properly, sorry, it may happen that you'll see the image formation there. There will be image here, but it will remain on the focal plane only. This is the only difference that you will see. But then our focus is right now this one, where the rays are parallel to the principal axis. Okay. Now, case number 2. Write down object is beyond C. Okay. So the object is on the left hand side of the C. You need to draw the ray diagram to find out where the image of the object will be. Don't take a point object, okay? Take an extended object, because we'll be talking about the magnification as well. This is the principal axis, and let's say this is F, this is C, let's say this is the object. Draw the ray diagram to find the image of this. Done?
Yes, sir.
So you just need 2 rays to find out the image, because the intersection, you need to also make sure that intersection of ray happens after reflection. Okay. So there is one ray like this. What will happen to this? It will pass to the focus. Okay. What will be the other ray? Anyone?
So through the center of curvature, then parallel.
So if the ray goes through center of curvature, what will happen to that ray?
Reflect parallelly to the
So
principal.
it will just come back through there.
It will just come back, right? If it hits the mirror, it will come back. What is the other I can draw? Any other ray that I can draw?
So you can pass through the focus.
If I pass to the focus, it will become parallel, right? Why it will become parallel? Parallel ray pass to the focus, and any ray that pass through focus will become parallel. The reason is that there exists only one path for the light to follow between the 2 points. Between the 2 points, it can go from A to B and from B to A. Same path it will follow. That is called principle of retraceability, which is something which can be, you can understand it as something which is obvious also, but it is in the form of law as well. So this is the ray diagram. So 2 reflected ray, this one and that one, intersects there, and you can say that there is an image here. What is the characteristic of image? Is it real or not? Is it real?
Yes, sir. Real inverted.
Real and inverted.
Inverted. What else I can say?
The form between focus and center of origin.
Between F and C. What else?
So diminished.
Diminished. These four things completely define what is happening with the image. Okay. So if an observer is looking at it, if observer is not looking at the object directly, but only looking at the rays that are coming out of the mirror, the observer will feel as if object is this, which is inverted. Okay. So this will be the characteristic of the image. So anytime, let's say, if I tell you that image is between F and C for a concave mirror, you can immediately understand that object should be beyond C. Okay. Case number 3. Object is at C. Draw this diagram, all of you. Case 3. Object is at C.
The lag.
Lag. Is there a lag, guys?
So slight.
Slight lag, sir.
Like how much? 2 seconds? 5 seconds?
Yeah.
So like last slide, there was a little bit like 2-3 second lag was there. When
So
you were
it's
writing the
manageable.
property. Yes, that's manageable.
Say it again. I could not get you. What is the last thing you said?
So it's manageable.
Okay, you please let me know whenever there is a lag. Don't wait for me to ask. If it is not manageable, immediately let me know. This is the concave mirror, and let's say this is the principal axis. This is F. This is C. The object is at C. Draw the ray diagram. This ray, other ray will go through the focus and become parallel. If you draw it to the scale, anyways, so if you draw that to the scale, you'll get the image at C only. Fine, you'll get it at C only. But since it is not drawn to the scale, that is why we are getting somewhere else. So this is what will happen. And characteristic of image will be same size, real, inverted, and at C. Okay, now you can see that the object has come from infinity to C. The image has come from where to where? If object goes from infinity to C, image goes from
Focus to see.
From
Focus to
center to edge.
image goes from F to C. So you can see that all the images of object locations between infinity and C is between F and C. So the object might be moving very fast, but the image of the object is going slowly because the distance covered is very less between F and C. The object is between C and infinity. Okay. Case number 4.
So over here, how can we find the velocity of the image? Like, let's
That
say
we'll
we know where the...
discuss it later on. When we discuss the formula, we'll discuss that. Object between... See, when we are drawing ray diagram for spherical mirrors, we can only do qualitative assessment. We cannot do quantitative assessment. I can only say velocity will be less or more. How much it is, that you'll get only when you know some formula. That we'll discuss later. Object between F and C. All of you draw the ray diagram for this case and tell me where the image will be. Characteristic of image.
So real, inverted, enlarged, and beyond C.
Okay. This is F. This is C. One ray goes parallel, goes like this. What will happen to this ray? Anyone? What will happen to this one? How will you draw for that line?
So the angle of incidence should be
Is
equal
this
to...
normal? Is this
Yes.
line normal?
That's normal.
That's normal only. So this angle should be equal to the angle of reflection. So when it reflects, angle should be equal. Okay. Right now angle is less. Make it equal. Like that. Okay. So this is how the two reflected rays will be. And you can see now your image is magnified. But still it remains inverted only. Okay. So it is real, inverted, beyond, C, and it is enlarged. Okay. This is case number 4. Now what will happen to the case when object is at the focus? Draw it, all of you. Case number 5. Object at focus, F. Over here. What will happen? Anyone?
Rays will be parallel to infinity.
Image will be formed at infinity. Which infinity? Left or right?
Left.
Left.
Why left?
So both sides actually.
Both sides.
Because even if you extend the rays, parallel rays will be parallel throughout, right? So
you'll get a real image on the left side.
Okay. So this is what you will get. Parallel rays. You'll get a parallel ray. Like that. Okay. it is coming out like that. If your observer will not be at infinity, right? Observer will be here only. Okay, for observer, these two lines will meet at infinity, the other side. All of you understand that? So image will be virtual. Please write down virtual, erect, enlarged, behind. Fine. This is the case for the image at F. Now you can see that the object is going from C to F. The image is going from where to where?
Focus to
C to F, the object is going, the image is going from C to infinity. Okay, so basically now you can see that the images are moving faster. Write down case number 5. The object is between pole and the focus. Case 5 or 6?
6.
6. Write down case 6. Object is between F and P. P is the pole. Draw the ray diagram, all of you. Draw it. See, I know the answer, and I know that everybody of you will know also. I'm not interested in the answer. Okay, I want you to draw it. Okay, everybody knows what is the answer. Don't type in the answer. Draw it and then say. Is F, this is C. All of you drawn?
Yes, sir.
Okay. So one ray goes like this, goes like that. The other ray, you can say, will appear to pass through the center of curvature. It will go back the same path. Fine. Like that. Now these two rays do not meet, but observer will feel as if the light is coming from their point of intersection backside. Okay, so they don't meet, but they appear to meet behind the mirror, and this is the image.
So the slight lag, sir.
Is there a lag? See, no one is saying, or no one has heard till now because of lag. Is there a lag? I'm writing here
a little bit.
No, so
I'm writing
like
M I
it's a little bit.
R O R. Was there a lag?
Yes, sir.
Yes, sir. Now it's
Still haven't done.
Yes,
Still
sir. There's a
hasn't
huge lag, I guess.
I still can't see it. Oh, I saw it now. Oh.
Okay, there is a lag.
Yeah. Yes, sir.
Okay, there is a lag. Understood. So let me reshare the screen. Wait. Now tell me, is there a lag? I'm writing something. M-I-R-R-O-R.
No lag, sir.
Oh no, that's
No, so I have
No lag, sir.
I have decreased the resolution. Earlier it was 10, what was that? 1024 megapixel HD quality. Anyways, so now what is the scenario? It is a virtual image magnified. Absolutely no lag.
Sir.
Great, yeah.
No, sir, there is a lag, I think.
No, there is no lag.
Yeah, now.
But now, now if I open the chat, everybody can see the chat. So I'll open it on the phone. You can speak up. Is there a lag or no? I'm writing something here. I'm writing M-I-R.
No, sir.
no, sir, no lag.
No lag. So those who are
No,
saying
sir.
there's a lag,
Yeah.
please look at your internet speed. Those who are saying there's a lag, please look at your internet speed. Okay, I will join by phone also. Okay, so I'll not open the chat because in this mode, the chat will be visible to everyone. See, you are able to see the chat or not? So I'll not open up the chat. So please speak up, okay? So it is virtual, it is magnified, the behind, it'll be behind. And what else?
So can we we can't pinpoint behind the mirror where it will be, right? Like with respect to the F and C behind the mirror.
No, you cannot. You cannot pinpoint where it is. There are no reference point outside. Okay. You just have to say beyond. That's it. Behind. Understood? Understood or not? Kaun tha bhai? Sai,
Yes,
you
sir.
were there? Who asked that doubt? Sai? Sai, are you able to hear me? Sai? Sai, you're muted. Okay. Anyways. So, we have discussed how the image will be formed by concave mirror. Okay. Now we will talk about the image formation in a convex mirror. Please write down convex mirror, how the image will get formed. So that's what we will be discussing. So this is, let's say, a convex mirror. It's a convex mirror. Of course, that side will be polished. The right side, left-hand side will be the surface which will be reflecting. So this is the principal axis, let's say. Where is the focus? All of you, focus will be where? Left-hand side or right-hand side?
The left
hand. Wait, no.
Right hand side.
Right.
Right-hand side, right? It will be right-hand side. This is F and this is C. Getting it? On the left-hand side, there is no reference point. So you cannot say object is placed between F or C or where exactly it is. You just have to say object is placed at whatever location. This is the object, let's say. Can you draw the ray diagram and identify the location of image, all of you?
So will it be between P and F?
Okay. one ray goes like this. What will happen to this ray? Parallel ray?
Appear to pass through the focus, and then you can extend it to the left.
It appears to pass through the focus. It will be like this. Okay. Of course, it cannot go inside the mirror. It will be like this. What will be the other ray you should draw?
Appears to pass through the C.
Appears to pass through the C. What will happen to this ray? Since it is perpendicular, the ray will just retrace its path. Okay, so it'll go like this, and it'll come back also along the same path. So these two rays will not meet. These two reflected ray, R1 and let's say this is R2, they will not meet, but they appear to meet over here. There is an image over there. So wherever you keep the object, in case of convex mirror, it will be virtual image. Can I say that? Every time it will be virtual image?
Yes, sir.
Okay, so please write down characteristic of image will be virtual, erect, diminished, and between, it will be always between P and F. Okay, so we have drawn the ray diagram of all kinds of mirrors, fine, including the plane mirror, the curved surface, everything we have drawn. So can we draw some inferences based on the ray diagram which we have drawn? Any inference we can draw? Can you say that if this happens, that will always be true? Something like that, can I say?
Since it's virtual, it's erect.
Correct. Please write down, if it is a virtual image, it will always be erect. Virtual images are always erect from the mirror. I'm talking about mirrors only, okay? If it is the image from the mirror, virtual images are always erect. Okay. What is the next inference?
The real image is always inverted.
Real image always inverted. Please write down, real images are always inverted. Virtual images are erect and real images are inverted. These are two basic inferences we have drawn, which will be always true. What else? Anything else? Can you draw inference?
So as the distance of the image from the mirror increases, the magnification also increases.
No, that is qualitative way of saying. I'm talking about something which is more direct, as in, you understand, it should be a statement sort of thing, not an explanation sort of thing. Anything else? But that is true. I'm not saying that is wrong. What else? Okay, please write down the next one. Third one is,
So I have a doubt.
Wait. First, you please write down what I'm saying. Then you ask out. Okay. Please write down, if it is an enlarged virtual image, if it is an enlarged virtual image, it will be from the concave mirror only. Yes or no?
Yes, sir.
Right? If virtual image is magnified, it will be from the concave mirror. And the next point, if it is diminished, if virtual image is diminished, it is from the convex mirror. Okay, so these are the four things there are many things you keep in mind based on whatever drawing we have done, but at least these 4 points you must keep in your mind, because these 4 points will be used in problem solving as well. Okay, what was the doubt?
So what happens if the object is placed at P for concave?
Say it again.
So what happens if the object is placed at P in concave mirror?
The image will be at P only. But that, why will you do that?
So just want to know.
No, nothing will happen. The image will be there only. Okay. We will now proceed further. Go to the next slide. See, till now we have found out the location of the image and the characteristic of image by using ray diagram. Okay, but then the problem is you cannot discuss everything by using ray diagram. As you know, if I tell you that there is a mirror of focal length 5 centimeter, object is kept at 10 centimeter, find the location of image, you'll have to be very, very careful in drawing free body diagram. You need to first make a mirror of radius which is given to you by doing some careful calculations. Then you need to draw, you need to identify where is F, where is R, and be very careful in identifying where the reflected ray will be intersecting. You need to draw it by using law of reflection. So all of that will lead to a lot of errors. Okay, in order to avoid errors, there has to be something or some formula which should be available to you, which will give you the answer directly. You don't need to draw the ray diagram. It should come out very, very accurately. For example, if you tell me what is the object distance and what is the focal length of the mirror, I should be able to put that thing in a formula and tell you exactly what is the situation with the image. Okay, right now we are not able to do it because we only know the ray diagram. I am looking at the formula so that my headache of drawing the ray diagram very accurately goes away. So that is the reason why the formula becomes very, very important. And the formula, as you guys know it already, this formula is called the mirror formula. So we are getting into the derivation of the mirror formula. A very popular question is asked, that this question is asked frequently to derive the mirror formula. So it is very important with respect to your school exams as well. In fact, we never went beyond your school in this session. It was everything was related to your NCRT as well, NCRT only. Okay, and only few things are beyond your NCRT for the JEE that we'll be doing once the topics are over. Mirror formula derivation we are getting into. All of you draw this. Now, when we do the mirror formula derivation, we need to draw the diagrams very neatly because a lot of labeling will happen. So make sure you draw the mirror and everything very, very neatly. So this is, let's say, mirror. It doesn't look symmetrical. Okay. This is the mirror. Draw it with me, all of you. This is the principal axis. This is F. This is C. Okay. I will draw an object now. This is the object. So let's complete the ray diagram first. All of you drawn the ray diagram? Ready with the ray diagram? This is where the image will be. This one. So I need image. This point is P. Let's say this is Q. This is R. You can say this is S. This is T. This is U. That is V. Okay. I'm assuming you have no doubts in the ray diagram. That's why I'm proceeding further. Okay. So what all things are given to you whenever someone asks you to find out the image from a mirror? What all things you require? You need to know the focal length, right? What is the focal length in the diagram? Which distance?
PF.
PF is known, PF or FP. PF is known. What else is known? Object distance from the pole is known. SP is known. What is not known? What do you want to find out?
Distance of image. PU.
Distance PU. You want to find PU. What else you want to find out?
UV.
UV. Or UV is the height of the object. So ST is given to you. The height of the object is given to you. Height of image you need to find out. So these three things are given to you. These two things you need to find out. Clear to everyone? That is what we need to do. Now tell me the first thing. What I should do? Construction. What is the construction?
Triangle, right triangle.
Draw the perpendicular. Hit the perpendicular. All the perpendicular will meet P only. It may appear that the perpendiculars are very far away from P, but then for our convenience, we have drawn a bigger and curved mirror. In reality, this will be very close to P. So all these points are P only. Point 1, point 2, point 3. Everything is P. Okay. Now, can you tell me two sets of similar triangles? Do you see any similar triangle?
QF and
PQF and P
and FV.
Triangle FVR and TUQ.
Correct. FUV triangle is similar to triangle FPQ. Okay. They are similar. And what else? Anything else?
Can we say the same about T,
FPR
FS?
and FQT.
Triangle TFS is similar to triangle
RFP.
RFP. You may be a little confused that F and P notations. This is F. All these points are P only. Okay, so I've drawn P there. Fine. So now I'm like my first interest is finding horizontal distances, right? SP, UP, FP. I want that in the equation. And also my interest later on would be to find the vertical distances. So my interest is horizontal and vertical distance only. My interest is not these slant lengths. Okay. So I will use ratio of sides of horizontal and vertical distances. So what I can say, the ratio of sides, how do I equate for the first one? First pair of similar triangle, what should I write? This one and that one. What should I write? These two are similar. Ratio of sides.
FU by FP is equal to UV by PQ is equal to FV by FQ.
Say it only one. Okay.
Sorry. FU by FP.
FU by
FP.
Okay. FU by FP is
equal to UV by PQ.
Correct. That's what FU by FP is equal to UV by PQ. All of you understood this? Ratio of sides. What about the second set? What should I write here? Using the second similar triangle.
PF by RF is equal to FS by FP.
Hold on. You can't just run through like this. Slowly you speak. What
So
it will
TF by RF.
PF. PF.
T, sir.
TF. Why are you taking slant height? You need to take the horizontal and vertical distances.
Okay.
That will be better.
TS by RP.
TS by RP. Correct. So TS by RP
is equal to SF by PF.
SF by PF. Now, how can I simplify 3 and 4? Anyone?
So can we say PQ is equal to TS?
Correct. So PQ is equal to TS. Yes or no? This is a line parallel to the principal axis. So its distance from the principal axis will be constant throughout. And I can say that UV is equal to PR. Okay. Fine. So I can say UV by PQ is equal to PR, which can be written as RP also, RP by TS. So this is true for the vertical distances, and hence I can equate the 100 distances from 3 and 4. I will say that FU by FP is equal to RP by TS is what? RP by TS is PF. PF, I'll write FP only. By SF. Now tell me, is it clear to everyone till now? Please ask doubts if you have any. This should be clear how it comes. Now I have to deal with only 100 distances. Everyone?
So it's clear.
Okay. Now, what all things are given to me? PF, if we talk about 100 distances, PF and SP are given, and PU is what I want to find out. Okay, PF is FP only. So FP and FP, they are given to me. Can I write FU and SF in terms of what I have and what I want to find? Can I write FU equal to something? FU, how can I write?
So PU minus
PU minus PF.
PU minus PF.
PU minus PF. That divided by, okay, now I'll write PF because numerator is also PF. FP is PF only distance. So I'll just keep on reversing it. SF is what? How can I write?
SP minus PF.
SP minus PF. Correct. So this is the relation which is there. So in this relation, all the knowns and unknowns are there, right? So if you tell me what is PF and SP, I'll tell you what is PU using this relation. Okay. Now the problem with this relation is that this is valid only for this case. Okay, it's valid only in this case. Suppose the image is virtual, so the point U will be somewhere here, and it will be a virtual image behind the mirror. Okay, so then FU will not be PU will not be PU minus PF. Then FU will be PU plus PF. Are you getting it? All of you? If it is virtual image, if it is virtual image, this will be U, then FU will be FP plus PU. Right now it is PU minus PF. So plus becomes minus then here. Similarly, here also plus will become minus if some other situation happens. So in order to make it situation neutral, I will have to come up with certain sign convention which will which will make sure that whenever image comes on left hand side or right hand side, it changes the sign accordingly. So if the distance has a sign also, then plus can become minus, minus can become plus, depending on the scenario. And then this formula you can say is general. So I'm trying to generalize the formula. Right now I have the formula only for this specific case. Okay. So I need to introduce something called sign convention here before proceeding further. So let me quickly introduce the sign convention. I will copy it down to the other whiteboard as well here. Okay. All of you, please write down the sign convention. Fine. Point number 1, all horizontal distances are measured from P as in pole along the principal axis. Okay. Horizontal distances measured along the incident direction or incident ray are positive. You have seen this sign convention before, as in class 10th?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
See, I'm not assuming that you have done anything in 10. Horizontal distances measured against the incident ray are negative. This is the sign convention for the horizontal distances. Now vertical distances, all vertical distances. I'm talking about height of image and height of object. All vertical distances measured along the perpendicular to the principal axis. Okay. Above the principal axis, distances are taken as positive. Okay. Below the principal axis, distances are negative. Got it? Okay. Now, I'm sure you guys know that focal length is represented by letter F, object distance is represented by letter U, and image distance is usually represented by V. Okay. So this is like a universal notation everybody follows. So we'll also follow it. Okay. So now tell me, focal length in the previous case, was it positive or negative? PF was positive F or negative F?
Negative.
Negative, right? So you can see that if you have to measure the focal length, you will have to start from the pole and then go towards the left hand side. Incident ray is coming like that from left to right. So you're going in the opposite direction of that. Fine. So PF is minus F. What about PU? PU is what? Object distance or image distance? What is PU? PU is the image distance. It will be positive or negative?
Negative, sir.
Negative.
Negative V. Okay. Now, what else is remaining? PF. PF is the object distance. This will also be
But
negative.
PF is done, sir.
Sorry, not PF. What is remaining? PU, SP. SP will be minus U. Now, all of them are negative. Okay. So, if I substitute there, I will get minus V minus of minus F divided by minus F is equal to minus F. All of you do this. SP is minus U minus of minus F. Okay. So from here, F square comes out to be V minus F multiplied by U minus F. Okay. So you'll get F square is equal to UV plus F square minus FU minus VF. So F square get cancelled away. You will end up with UF plus VF is equal to UV. All right. Now, in order to write in a more elegant manner, we are dividing this entire equation by UVF. So you will get 1 by V plus 1 by U is equal to 1 by F. Okay. So this is the mirror formula. All of you write down, this is the mirror formula. Now, when we use the mirror formula, and if suppose object distance is 5 centimeter, then you'll have to again write U is equal to minus 5. Okay. In deriving also, while you're deriving, you use sign convention. While you're substituting value, then also you have to put this value of U, V, and F with the sign convention when you're putting the value. Clear to everyone? Any doubts? Please ask.
You repeat that when you have to put sign convention.
What I'm saying is that if it is given object is 5 centimeter from the mirror, then U should be written as minus 5 centimeter when you're putting it in this equation. Getting it? That's what I mean.
Okay. Okay.
You have to use a sign convention again while deriving as well as while using the formula.
Okay.
No other doubt? Okay. So this is for the horizontal distances. Now let's quickly talk about the vertical distances as well. I'm trying to find out the magnification. What is magnification? Anyone? What should be it? Magnification should be height of image divided by height of object, right? It will tell you how many times the image of, how many times the height of image is compared to height of object. Okay. In order to find that out, we have to draw the ray diagram quickly. All of you draw this. This is the principal axis. Okay. Let's say this is the object. This is the object. Now suppose the image location is known to me. Okay, I don't need to draw the ray diagram to find the location of image. I can just draw this one line and the other line. I know the location of image by using the mirror formula. So this is it. If I write it as this is P, Q, R, S, and T. Okay. Are these two triangles similar? Triangle RQP, is it similar to triangle SPT? Are they similar or not?
Yes, sir.
Yes, sir.
Yes.
Right. So since they are similar, again I'll use a ratio of sides of base and perpendicular. I can say that PQ divided by PS is equal to QR by ST. Now using sign convention, can you tell me how this will get modified? Anyone? PQ is the object distance. PS
Minus,
is the, tell me
minus
PQ is?
U by V.
PQ is what? V or
Minus U. Minus U.
minus U, correct. And PS?
Minus V.
Minus V. QR?
Plus HI.
HO, it is height of object.
Yeah, object, sorry.
Divide by?
Minus HI.
Minus HI. You are using the sign convention because sometimes the height or the image will be erect. Okay, so that should be taken care of. So that is why using sign convention in the case of height as well. So if you get negative magnification, it gives you an indication that the image is inverted. So HI by HO, height of image by height of object, is minus of V by U. Okay. This is the magnification formula in case of mirror. Okay. So we have derived the mirror formula and the magnification formula. So both horizontal and vertical distances we have derived. Fine. So I'm stopping here. Tell me whatever we have discussed till now from start. Any doubts? Because now we are going to take up numericals. Any doubts since start? All of this you have already studied in 10th, I suppose, and this is where your 10th stops. From next class onwards in optics, you'll go beyond your 10th curriculum. But whatever you've discussed till now, any doubts? Anyone? No doubts? All right. Okay, I'll just check for the lag because this type of sharing doesn't enable me to see your chats. So let me know if you see any lag. Okay. Now tell me, is there any lag? I'm writing here A, B, C, D, E. Was there a lag?
Sir. Yes, a little
Yes, sir,
bit.
a little bit, but it's manageable.
So earlier was much better, is it?
Yes, sir. The audio was better.
No, sir, bad quality is not nice. This is good. So could you make a poll?
Kya poll? About lag?
No, like whether they prefer higher quality with a little lag or worse quality.
This is not a movie, right? These are all just text. It doesn't matter quality wise. But anyways, since you're asking for poll, here it is. Let me check which poll to give. Take the poll.
So what
What is
which
A and
option?
what is B?
Good question. A is what is A is high quality, B was a previous quality. A is with lag, B is without lag. Lag was very less, I suppose.
The lag
Okay.
is not that much.
I will just modify the settings a bit from next time onwards. There will not be any lag. Okay, so 50-50%, not much of a difference. See, in this mode, I can see the chats and you'll not be able to see my screen. In the other mode, if I open the chats, everybody can also see the chat. Okay. I'll just check once again. Let me know if there is any lag. Let me know.
Yes, sir, there's a lag.
Yeah, sir.
How much?
So
Bit
it's like
less.
So like when you started, if
so.
then we saw the full thing.
when you're like stuck, yeah.
Oh, okay,
Exactly.
okay. So we'll go to the previous mode only. We cannot compromise that. Now, are you able to see without lag?
This time there is no lag.
No lag. Okay, we'll keep it like this. Can somebody type in some message? Are you able to see my chat screen?
No, sir.
No, sir.
No, sir.
No. Oh, thank God. So that was the. So earlier I had shared full screen. Now I'm sharing only part of my screen. That is a trick. Got it. Fine. So like I said, we will go to the problem solving since nobody is asking any doubts. So yeah, so let's take up the question. Param will take some basic question, then we'll get into the speed and all, okay? I'll not jump into the advanced level straight away.
Okay, sir.
This is a just 12 class. Okay. Fine. So all of you, please do this basic question. I'll take it from your NCRT only first. Let's take your NCRT basic questions. So here is a question. An object is placed at 5 centimeter and 10 centimeter in front of concave mirror of radius of curvature of radius of curvature if I give of 10 centimeter. Okay, you need to determine the location and characteristic of image in both the cases. You need not even use the formula, but anyways, it's up to you. Find out. Okay, Vikas answered. Others?
Answer.
So focal length is how much? 5?
5.
10 by 2, 5. So in first case, the object is kept at the focal point only. Okay. So the image will be infinity in case number 1. And in case number 2, the object is kept at the radius of curvature. So the image will be inverted and at the same position where the object is and the same size. We have done this, right? We have been drawing the ray diagram. All of you clear, right? Focal length is r by 2, which is 5 centimeter. So in first case, the object is kept at the focal length, image will be infinity. In second case, the object is kept at radius of curvature, so the image will be inverted, same size, at the same location. And both the cases, sorry, in at least in this case, it will be real image. The first one, it will be virtual. All right, so this is basic warm-up exercise, and I hope you can appreciate that every time you should not run behind the mirror formula. Okay, you need to use your brain. You need to understand that at times you don't need to, you can just visualize and understand what is the answer. Next question. This is a mirror. Okay. Let us say I have a square box. Okay. No, not a box. It's a two-dimensional thing. It's a square. Fine. It's a square. This is F. This is C. So the square box starts from C and goes back by a distance of F by 2. So basically the side length of the square frame is F by 2. The length of the square frame is F by 2. Okay, understood? You need to find the area of the image of this square frame. Have you understood the question?
Yes, sir.
Okay, find out. Okay, someone is telling the answer. Okay. Should we solve now?
Yes, sir.
So just 1 second.
Okay. This is, let's say, 0.1, 0.2, 0.3, and 0.4. Okay. Now let's just look at 1 to 2. 1 to 2. The image of 1 to 2 will be how? Anyone?
Below C. Below C. Same.
Below C.
Below
Up,
C.
up to what height? F by 2 only, right?
By 2.
F by 2 only. Now, where the image of this will be? This is at a distance of
Between C and F.
So halfway between C and F.
halfway between C and F. How? Let's
Wait,
try to
not
find
high.
out. Let's try to find out. Wait. A is equal to F by 2. Okay. So the mirror formula is 1 by V plus 1 by U equal to 1 by F. I'm trying to find out the image of that side whose location is U is equal to what? 2F plus F by 2, right? From here, from PC plus C to 4. So this is 5F by 2. This is U. I need to find V. So please remember that whenever we are writing in terms of variable, you don't need to use sign convention. When you are writing a value, then you need to use a sign convention, because when you write U is equal to 5F by 2, the sign is automatically taken care of. When you write the value of F, it automatically becomes negative later on. So 1 by V plus 1 by 5F by 2 is equal to 1 by F. 1 by E is 1 by F minus 2 by 5F. This is how much?
5. So V will be 5F by 3.
V will be 5F by 3. 5F by 3.
Also, now do you write V 5F by 3 as 2F minus something?
Hold on. V is equal to 5F by 3, right? So it will be less than 2F. So it will be between C and F. And it will be magnified or diminished. Anyone? Diminished. So it will be little lesser, like that. So this is the image of 3 and 4. So I can say this is 3, this is 4, this is 1, that is 2. Okay. So you can, approximately say that it becomes a trapezium, like that. Of course, this may not be a straight line, but I'm assuming that, it will be a straight line just for the sake of simplicity. So you'll get a trapezium like this. Okay. Now, 3 to 4 height will be what? That is height of image divided by height of object will be equal to minus of V by U, right? V is equal to 5F by 3. U is what? 5F by 2. Okay. So height of image is equal to what comes out? 2 by 3 minus of 2 by 3 times
1 by 2.
Ruchir, hold on. I'm solving in between. You're asking what is the answer. I'm telling something, right? So HI will be equal to mine. So I was talking to Ruchir Singh, not Ruchir Parekh. So Ruchir Parekh stopped. Anyways, so HI is minus 2 by 3 times HO. HO is what?
F by 2.
F by 2. So this is equal to minus of F by 3. Now I have drawn it wrong here. It is actually inverted image, right? So this will be 4. This will be 3. Okay. Yeah, same thing. So this is, you will get a trapezium like that. This is F by 3. That is F by 2. And distance between the parallel side is how much? This is what? This distance. Anybody found
F
that?
by 3. F by 3.
F by 3, sir.
F by 3. So the area is what? Area of the trapezium is half of sum of parallel side F by 3 plus F by 2 into perpendicular distance F by 3. At least one tricky question I have to do. So that's why we have taken this up. Hope you understood, all of you.
Yes.
Any doubt? Now you asked out. Ruchir Singh, what was your doubt?
So I took like thin strips and their image distance will be X, and then I started integrating it.
Yeah, that's what
Would
even
that
I
still
did.
work?
Yeah.
Yeah, that will give you the exact value of area.
So even I did that.
Yeah, I understand that. That is why I quickly started solving. Fine. There's nothing wrong in using integral. But then I wanted you to go through this the way we have analyzed. Final answer, like I said, not important. What is important is you need to see how we navigated. Okay.
Sir, I had a doubt, sir. So in that point 3, sir, how would the ray travel through the square to get reflected? So the backside of the square, for the ray to be formed, it would have to pass through the square, right?
It will pass through the square. We are saying that it will block the ray.
Yes, sir. That's what I felt, that the back part of the square won't be visible.
Oh, like that. Yeah. Then you're correct. But little bit of, suppose it is transparent or suppose it is slightly tilted, then it will allow the ray to pass.
So, but that only
So
works
even I
if we
had the
consider it as 2D. But since it's 3D, we can say that the reflected square is the surface.
It is not 3D. It is 1D only. Oh, you say, are you saying that the mirror will be 3D?
So isn't this like a 3D situation?
No, the square is 2D. I repeated a couple of times that it is.
Oh, okay.
Okay, but Ruchir, yes, he has gave a very nice hint here that the mirror is not a 2D figure. Mirror is 3D. It comes out of your screen also. So it will not be able to block the rays.
Understood, sir. Thank you, sir.
Okay, so let us take a few more questions. You have a mirror like this. Okay. And suppose focal length is given f. Okay, focal length is given. The object is, a small object is kept here. A small object is kept here. The length of the small object is delta L. Okay, that a small object is at a distance of it is at a distance of 3 times f from the pole. Okay, you need to find out the length of the image. The delta L is length of the object. Delta L of the image is how much? Again, I'm repeating, delta L is very small. Try doing it. See, I'm taking different kind of questions, so you may not be able to solve it because you're looking at it for the first time. So I cannot solve a same type of question 5, 6 because then the time will just go. I'll not be able to tell you the varieties of questions. So
So
that
can
is
you
why.
repeat the
Hold
what you
on.
have to fill?
Don't interrupt me.
Sorry.
Hold on. So what I'm saying is I'm going to take up different types of numericals and they are completely disjoint from each other. So it may happen that you're not getting many of these, but that is fine. First time you're looking at it. I want you to try it out and then learn it when I solve it. Okay. So this is a situation. Delta L is very small. Delta L is the size of object. You need to find size of the image. Delta Li. Do it. All of you tried. Now I'll do it.
So 1 second.
There is a small trick, so that's why I'll not be surprised if you don't solve it, but you should know the trick. That's why I've given you this question. Okay. So 1 by V plus 1 by U is equal to 1 by F. Okay. Now differentiate this equation with respect to V. What you'll get? Minus 1 by V square minus 1 by U square du by dV is equal to 0. Understood? So du by dV is equal to minus of V square by U square. From here, no, U square by V square. Are you able to understand what I've done here, everyone?
Yes, sir.
Derivative understood, right? So dV is equal to minus of V square by U square du. You need to understand one thing, that this delta L is not height. Delta L is the distance along the axis. That's why that can be represented as du as long as delta L is very small. Okay, so that's the reason why we are getting du here. dV is delta L of image. That will be equal to minus of V square by U square into delta L of object. Now U is given to us. U is what? Minus of 3F, right? How to get V? Use this mirror formula. So I can write 1 by V minus 1 by 3F is equal to 1 by F. Okay. So 1 by f is 1 by v is 1 by f plus 1 by 3f. So v is how much?
3f by
3f
4.
by 4. Okay. Again, I have used sign with f. It should not be used. Sign should not be used. Sorry about that. It should be plus. F is a variable. F is a variable. If I'm using sign with f, I need to use sign here also. 1 by f also should be written as 1 by minus f. Okay. So v will come out to be 3f by 2, right? Minus of 3f by 2. No, 3f by 2. So delta L of image is equal to minus of v is 3f by 2. It will be 1 by 2 whole square delta LO. So this will be minus of delta LO by 4. This is what it is. Why minus is coming in? 1 and 2 will spread like that. This will be 1, that will be 2. It will invert laterally. Not laterally, as in a straight path. The front will become back, back will become front. That's why minus is coming. Okay, any doubts? Anyone? Quickly ask, any doubt?
So can you do it in a different method? Like, is it possible?
See, different method you'll get the same answer, but it will be lot more complicated. What will happen is the distance is given from distance of object is given from the mirror. It is not that distance of front is given, that first distance of back is given. You need to find out image of, let's say 3f minus delta L by 2 is front side and 3f plus delta L by 2 is the back side. Like that, if you do, you'll get the location of image and object, then take a difference to get the distance of the or the length of the image. It will be a lot complicated. Don't try to do in other way. Why? The reason I've taken this question to tell you that such tricks exist, please use it. That is the reason I'm giving you this question. This is not an exam where you should get it right. I know that none of you will get it, but you should know this trick. That is why I'm giving it to you. Okay. Any other doubt? Anyone? Any other doubt? No one? No doubts? Okay, next question. All of you. You have a mirror, a concave mirror of focal length, let's say of 10 centimeter. Okay. This is F and this is C. Okay. Focal length is 10 centimeter. There is an object. There is an object which is at a distance of, this object's distance at present is 40 centimeter. Okay. And this object is moving forward with a velocity of 2 meter per second. Okay. You need to tell me the velocity of the image, how much it will be. You can take the hint from the previous question, something like that you have to do here as well. Okay, someone got the answer. Param got it. Vikas got it. Ruchir got it. Chaitanya. But you're getting different answers, all four of you. Others, I'm waiting for everyone. Please answer. Should I discuss now?
So 1 minute.
All right, now that everyone has at least attempted, we can discuss. Okay, fine. So 2 by 9 is a very common answer people are getting. Let us see whether that is true or not. All right, so 1 by V plus 1 by U is equal to 1 by F. So in kinematics, we have been using V and U as the velocity. The first time we are, U and V are distances. So do not get confused. So the velocity of the object is what? Du by dt, right? And velocity of image is dv by dt. So I'll differentiate it with respect to time. So minus 1 by v square dv by dt, which is the velocity of image, minus 1 by u square du by dt, this is equal to 0. So from here, dv by dt is equal to minus of v square by u square times du by dt. Okay. Now, can anyone tell what this minus sign signify? Anyone?
So it's moving
Opposite
Moving towards the
direction.
left. Yeah.
Like
Towards the left.
negative.
So it is in opposite direction. The velocity du by dt and dv by dt, the velocities of image and object are in opposite direction. That's all. Okay. Now, du by dt is given as 2. U is also given. V is not given. So let's try to find out V. So 1 by V, U is what over here? U is minus 40 according to sign convention. And F is minus 10. So 1 by V is equal to minus 1 by 10 plus 1 by 40. So V is equal to how much?
Minus 40 by 3.
minus 40 by 3.
Minus 40 by 3 centimeter. Okay. So dv by dt will become minus of 40 by 3 divided by what? Divided by 40. There is a minus sign here, but square happens, so minus goes away. Du by dt is 2. So you'll get minus of 2 by 9 meter per second. Okay. Is it fine with everyone?
Yes, sir.
Okay, so this is how you deal with the velocities with respect to the thing. Now tell me one small thing about this question. du by dt represents absolute velocity or relative velocity? What it is?
So it's
Over
relative
here,
think
velocity with
relative.
respect to the mirror.
relative to mirror. Please write down. It is relative velocity with respect to mirror. Since mirror is at rest, right now relative velocity is same as absolute velocity. Relative velocity with respect to mirror. If mirror is moving, you need to take care of that fact. dv by dt similarly is relative velocity with respect to mirror. These are very important things. So if a J advanced question come in this topic, they will trick you in these matters only. There are not many things to trick you over in the chapter, but these finer details will trick you. Anyways, let's take the last question for today. No doubts, right? On this one, I'm going to the last question. Okay. So you have a mirror, let's say like that. You have a mirror like this. This was a mirror in with you. What you have done is you've broken into two. So you created two mirrors out of it. One mirror you moved up one part and one part you moved down. Like that. Okay. So this is the situation. This was an earlier principal axis. This is the situation. Focal length is 10 centimeter. Okay. So basically an object is kept over here. Object distance is this distance from here to that. This distance is 20 centimeter. It is kept at the radius of curvature. Okay. This distance is x. That distance is also x. You need to find the location of image, where it will be. Is it moved such that center of curvature is still the same? What do you think center of curvature will be for the upper part? Everyone, where it will be?
Yeah, it will be above.
It will be moving up, right? It will move up. So basically, there will be two principal axes now. This one and that. For the above one and one for the below one. Two principal axes you'll see. That was the hint. Now tell me. Should I solve? Does it matter to the horizontal distance? If you use, can I use 1 by u plus 1 by v is equal to 1 by f for only the upper part of the mirror? Can I use this? Anyone?
Yes, sir.
right? So I can use it. It doesn't matter how much mirror you take, only this much or that much or this much, the mirror formula remains same. Okay, because of which, since it is a center of curvature C, the distance is radius, so the image will be at the radius only. Yes or no? All of you understand?
Yes,
So right now, since that is a principal axis, I can say that tip of this object is the tip of this arrow is the object. This is the object. It behaves like an extended object. So when the image gets formed as center of curvature, it will be inverted. It will be like this. Okay. So at a distance of x above will be the image of this object from the above mirror. Understood everyone? This is the first image, I1. And similarly, this object can be the arrowhead of this arrow for the below one. So again, the inverted image gets formed because it is kept at the center of curvature. So you will get inverted image of the same height. Okay. So another image over here will get formed, I2. Okay. I1 and I2 will get formed in such a manner that the distance between them will be 4x now. So two images will get formed 4x distance away, but it will be at the center of curvature distance only. Any doubts with respect to this question? Please ask. Anything? Two images will get formed, one from the above one from the below one. Tell me.
No doubts.
Can we also solve by rotating the principal axis? What do you mean by rotating the principal axis? You mean to say that you want to take this as your principal axis? That one? No, don't do that way. I mean, I'm telling you the simplest way of visualizing the scenario. Okay. So now you are equipped with visualizing the scenario whenever you split the mirror like this. Okay. So attempt it like this. Your point object will behave like an extended object of this much for the above mirror, and the point object will behave like an extended object of this much for the below mirror. Okay, two principal axes you can treat these two. Any other doubt? Anyone?
Sir, is the image formed a point one or an extended one?
What say it again?
Sir, is the image that is formed a point image or an extended image? The two images.
Point. You get 2 points.
Okay, sir.
You get 2 points, but you are visualizing as if it is extended one. Okay, it is not extended, but you can, if you take it extended, right now it is center of curvature, so you know exactly what distance it will be above. But suppose it is not center of curvature, then you have to find the magnification of this extended one and then identify where the tip of this object will be. That is your image.
Okay. Okay, sir. Understood, sir.
Right now it is simple. You have kept it at center of curvature. All right, guys. So that's it from my side today. At the end, we have taken some tricky questions, and believe me, there are not many tricky questions. So I have taken, I think, 50 to 60% of all the tricky questions already. But then you should know how you can apply the tricks in the ray optics. So if you just practice a little bit on whatever we have done today, you're good to go at any level, mains or advanced also. Not many varieties are there in the ray optics. So make sure you do the ray optics very, very properly and ensure 100% marks in the ray optics. And in wave optics also. Both are simple chapters. Fine. So that's it for today. We will meet again next week. Take care.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you.
Thank you.
Thank you, sir.
Yes, sir.
Yes, sir.
Yes, sir.